Okay, so in this video I am explaining concept of Chebyshev filters. So this is classified as in different ways. The first one is history of Chebyshev filters, and the second task is order calculation, and third task is poles calculation, and the next task is advantages of Chebyshev over Butterworth, and next task is evaluation level. So evaluation level means, so what are the further improvement to do by the researcher or the students so that they can easily develop the further level. That's why it is called as evaluation level. So coming to the history of Chebyshev filter or origin of the Chebyshev filters. So in the 1960, Daniels Lutovac introduced filter characteristics from the Chebyshev polynomials. So that's why this name is, it is named it as a Chebyshev filters. So coming to this order calculation of Chebyshev filters. So this is the formula they derived, that is h of j omega is equals to 1 by root over eta square or epsilon square, whatever it may be. This is a parameter variable cn square omega by omega p. Here omega p is the pass band. So here squaring both sides, h of j omega whole square is equals to 1 by eta square or epsilon square cn square omega by omega p. So this is here, this is what is called as a Bessel's function. Here the Bessel function, this is the notation of the Bessel function, and during the pass band C of n omega by omega p is approximately equal to cos capital N cos inverse omega p is the pass band when this value is less than 1. And coming to this Cn of omega by, that means this Bessel function can be written as cos h n cos h inverse omega p is the under stop band. That means when it is omega by omega p greater than 1. Coming to the poles calculation, here the denominator of the given transfer function or derived function is equals to 0. That is 1 plus eta square cn square omega by omega p is equals to 0. So by simplification and substitute this s is equal to j omega, so is equals to, we can write this as s by j, that means minus s by js, simple mathematical complex variables. So 1 plus omega square cn, this equals to 0. So that means finally plus or minus j by j eta is equals to cos n cos inverse j minus js by omega p. So by using a proper mathematics analysis, so finally these are the poles of the Chebyshev filter. Sk is equals to omega p of minus sin phi mu 1 by n minus mu 1 by minus 1 by 2 plus j cos mu power 1 by n plus mu power minus 1 by n by 2, where mu is equals to eta or epsilon minus 1 plus root over 1 plus epsilon square minus 2. This is what the pole calculation have been done. And coming to the advantages of Chebyshev over Butterworth. In the first point, in Chebyshev, ripples are existing in the pass band and also as well as in the stop band. But whereas in the Butterworth, there are no ripples in the pass band as well as the stop band. They are monotonically decreases as the frequencies increases. Coming to the second point, their transition is very less than the Butterworth. Yes, Butterworth's transition is very high. So that's why the bandwidth is that means attenuation in the stop band is very less in the case of Butterworth, but whereas the transition is very less in the case of Chebyshev. Next, the poles of the Butterworth are circular, whereas the Chebyshev filters are elliptical. And the final point of this advantages, the number of poles are in Chebyshev are less than the Butterworth for the same specification. Yes, for the same specification, the number of poles, if you go for calculate the number of poles, Butterworth is very high, but whereas compared to the Chebyshev have less number of poles. To the evaluation level of this Chebyshev filter concept. In the first case, so we can implement the poles replacing cos function, because already in this we have seen that in the Bessel functions cos of capital N cos inverse of x, that Bessel functions is implemented, but in this we can replace this, we can calculate the number of poles by using cos of x or sin of x. we know the cos of x. That means cos of x is 0 plus x square by factorial 1 plus x 4 by factorial 4, and even functions. Similarly, sine is 1 plus x power 1 by factorial 1 x cube by is odd number of functions. So we can simply replace the function with cos h expressions. That is, suppose if it is a cos x, then we can write it x square by factorial 2, x square by factorial 4, so that if that function is replaced in the Bessel function, then we can calculate the approximate poles. This is how we can furtherly implement it Chebyshev filters concept poles. And similarly, second point, coming to we cannot do further we can do further filters by replacing Bessel's function. Yes, in the denominator Bessel's function is replaced by something else filter, something else functions pole numbers, then we can implement do further research. Next, third point, we can do research and calculate by introducing both Chebyshev and Butterworth in the same function. Yes, in the denominator functions we can replace both Chebyshev as well as the Butterworth functions, so that it leads to a hybrid functions. This is how we can we can do more research, and we can implement more number of further filters.